Picture California, 1849. Thousands of people abandon their lives, pack everything they own, and rush west chasing the promise of gold. Most of them fail. Most go home broke, exhausted, and disappointed. But there's a smaller group that quietly gets rich during the same period. The people who never picked up a shovel. They sold the shovels. They sold the picks, the jeans, the mules, the tents, the wagons. They didn't bet on which miner would strike gold. They bet on the fact that all of them needed gear. Now fast forward almost 2 centuries. OpenAI, Google, Meta, Microsoft, Anthropic, and thousands of startups are in the middle of their own gold rush, eating. Except this time the gold is artificial intelligence. They're racing to build smarter chatbots, better image generators, autonomous agents, AI co-pilots, and entire new categories of software. And while they sprint toward that gold, one company is selling them almost everything they need to dig. That company is Nvidia. So the real question isn't, is Nvidia a hot stock? The real question is much more interesting. How did a company once known for making graphics cards for video games end up becoming the indispensable infrastructure of the entire AI revolution? Because once you understand the answer, you stop seeing Nvidia as a chip maker. You start seeing it as something much stranger and much more powerful. Let's set the stage. When most people think about the AI boom, they think about the apps. ChatGPT writing essays, Midjourney making art, GitHub Copilot writing code, AI agents booking flights, self-driving cars, AI video generators, robotics. That's the surface of the wave, the part you can see and touch and play with on your phone. But underneath every single one of those apps is something invisible and enormous: compute. Modern AI runs on 3 pillars. The first is data, the raw material the models learn from. The second is algorithms, the mathematical recipes that turn data into intelligence. And the third is compute, the sheer amount of calculation needed to train and run these systems. Of those 3, compute is the most physical, the most expensive, and the hardest to scale. You can't just download more of it overnight, you have to build it. Think of it this way. Training a large AI model is like constructing a knowledge factory from scratch. It takes weeks, sometimes months, of nonstop calculation and inference. Every single time someone types a question into ChatGPT or asks an AI to summarize an email is like running that factory at full speed in real time for millions of people simultaneously. Both phases are hungry, and both phases run on GPUs. This is why Nvidia's numbers in fiscal 2025 are so striking. The company reported revenue of $130.5 billion, with the data center segment alone accounting for $115.2 billion. That's not gaming money anymore. That's not enthusiast money. That's the economy of an entire industry being routed through one company. But here's the strange part. Nvidia didn't start with AI. Nvidia started with games. Long before anyone outside academia cared about deep learning, Nvidia was a graphics company. Their GPUs existed for one reason: to render beautiful, fluid, real-time 3D worlds for video games. Think about what that actually requires. Every frame of a modern game has millions of pixels, each one needing color, lighting, texture, and motion, calculated 30, 60, sometimes 120 times per second. That's an absurd amount of math, but it's a very specific kind of math. It's repetitive. It's parallel. It's the same operation done millions of times at once. This is where the difference between a CPU and a GPU starts to matter. A CPU is like a small team of geniuses. Each one is incredibly fast, incredibly versatile, and great at solving complicated sequential problems one step at a time. A GPU is the opposite. A GPU is like a stadium full of people, each one doing a tiny calculation simultaneously. None of them are geniuses, but together they can crush a massive parallel workload that would choke a CPU. For years, this architecture was tied tightly to gaming and graphics. But Nvidia's leadership saw something most of their competitors missed. They started believing, long before there was hard evidence, that this same parallel architecture could be useful for almost anything that involved heavy mathematics. Scientific simulations, weather modeling, physics research, cryptography, and eventually machine learning. So Nvidia made a deliberate, almost philosophical bet. The GPU shouldn't just be a graphics card. It should be a general-purpose computing platform. But to make that real, fast hardware wasn't going to be enough. They needed developers to actually use it. And to do that, they needed to give the world a language. Here's the thing about modern AI, and especially deep learning. Underneath all the complexity, the neural networks, the training loops, the transformer architectures, almost everything reduces to one operation: matrix multiplication. Lots and lots of matrix multiplication. When a model learns, it's adjusting billions of parameters by doing massive amounts of linear algebra. When that model answers your question, it's doing the same thing in reverse, just at a smaller scale. It's math, repeated at unimaginable scale. And this is exactly the workload GPUs were born to handle. They have thousands of small cores instead of a few big ones. They're optimized for throughput rather than latency, meaning they care more about how much they can finish in total than how fast any single task completes. And they're tuned, almost spiritually, for the kind of repeated, parallel arithmetic that matrix math demands. Here's the simplest way to think about it. If a CPU is a Michelin-starred chef who can make any dish you ask for one at a time, a GPU is an industrial assembly line that can perform the same simple step 1,000,000 times in a second. AI training doesn't need a chef. It needs the assembly line. And Nvidia didn't just notice this and stop. They kept pushing. Each new generation of their data center GPUs has been more aggressively tuned for AI workloads through architectures like Hopper and now Blackwell, where Nvidia attributes its fiscal 2025 growth to strong demand for Hopper systems and the start of Blackwell shipments in the fourth quarter. So you don't need to fully understand neural networks to grasp the punchline. AI does an unbelievable amount of similar calculations all at once, and GPUs were essentially designed to do exactly that. But hardware advantage alone doesn't explain the moat. The hardware is only half the story. In 2006, Nvidia released something called CUDA. On paper, CUDA was a computing architecture that let developers use GPUs for general-purpose computing, not just graphics, along with a C-style compiler that made it accessible. In practice, CUDA was the most important strategic decision in Nvidia's modern history, because CUDA turned a piece of hardware into a platform. Think of it this way. If a GPU is a jet engine, CUDA is everything that surrounds it: the cockpit, the controls, the maintenance manuals, the pilot training programs, the airports, the fuel supply, the entire industry that makes the engine actually useful. Without that ecosystem, even the best engine in the world is just a heavy lump of metal. And once Nvidia built that ecosystem, something remarkable happened. A flywheel started spinning. Developers learned CUDA in school and at work. AI libraries got optimized for CUDA first. Frameworks like PyTorch and TensorFlow ran best on Nvidia hardware. Research labs published papers using Nvidia GPUs, and the next generation of researchers grew up assuming Nvidia was the default. Startups built their stacks on top of those frameworks. Cloud providers responded by buying more Nvidia hardware to meet developer demand. Every single layer reinforced the others. This is what Nvidia calls a full-stack computing platform: CUDA. The CUDA-X libraries, APIs, SDKs, and domain-specific frameworks for everything from genomics to autonomous driving. Nvidia's own materials describe an ecosystem with hundreds of libraries, hundreds of AI, XRI, Hiwin models, and tens of millions of downloads. That isn't a feature, that's a moat. Because even if a competitor built a chip tomorrow that was faster than Nvidia's flagship, they'd still have to convince every developer, every framework, every researcher, and every cloud provider to switch. And switching is painful. So Nvidia didn't just win because their chips were fast. They won because they made themselves the default for an entire generation of AI builders. And when the world finally needed AI to explode, Nvidia already had the hardware, the software, the ecosystem, and the relationships in place. All they needed was a spark. That spark came in waves. First in the early 2010s, when deep learning quietly took over computer vision and speech recognition. Then a much bigger detonation in the early 2020s with generative AI, large language models, image generators, and eventually tools like ChatGPT, which dragged AI out of research papers and into the mainstream conversation almost overnight. And as the models got bigger, the compute requirements went vertical. Suddenly, training a state-of-the-art model didn't mean buying a few high-end GPUs. It meant assembling tens of thousands of them, sometimes more than 100,000, into massive data center clusters that consumed entire small power plants. Nvidia's customer base shifted underneath them in real time. The old customers, gamers, workstation users, individual researchers, were still there, but they were dwarfed by a new tier of buyers: hyperscalers, cloud giants, frontier AI labs, and even nation-states racing to build sovereign AI infrastructure. AI stopped being a piece of software you ran. It became something you had to build, brick by brick, GPU by GPU, rack by rack. And that changed the questions everyone was asking. The smartest founder with the best research idea couldn't win on cleverness alone anymore. The new questions were brutally physical. Who has enough GPUs? Who has fast enough networking between those GPUs? Who has a stable software stack that won't crash a training run 2 weeks in? Who can scale a training cluster to 100,000 chips without melting it? Who can run inference cheaply enough to actually make a profit serving millions of users? Suddenly, Nvidia wasn't just a vendor. Nvidia was a bottleneck, a choke point that the entire industry had to negotiate with to move forward. This is where the gold rush metaphor stops being cute and starts being precise. Look at who's actually digging for AI gold right now. OpenAI is digging through chatbots and APIs. Google is digging through Search and Gemini. Meta is digging through open models and social platforms. Tesla is digging through autonomous driving and robotics. Microsoft is digging through enterprise AI and Copilot. Amazon is digging through cloud services, and around them thousands of startups are digging in every imaginable vertical: legal AI, medical AI, coding AI, sales AI, video AI. Now look at who Nvidia sells to, almost all of them. That's the genius of the business model. Nvidia doesn't have to predict which AI app will win. They don't have to bet on whether ChatGPT or Gemini becomes dominant. They don't need to know whether the next big thing will be agents, robotics, or something nobody's named yet. As long as the race continues, the racers keep buying picks. And here's the sharper edge of the insight. Nvidia doesn't just benefit from the eventual winners. Nvidia benefits from the competition itself. The more aggressively these companies fight each other, the more compute they buy. The more clusters they build, the bigger their orders get. Rivalry is rocket fuel for the pickaxe seller. But this is exactly the point where a careful viewer should start getting suspicious. Because if selling pickaxes is this profitable, you'd expect a swarm of competitors trying to take that business away. So why hasn't anyone managed to do it? Nvidia is not the only company on Earth that knows how to make a chip. AMD makes powerful GPUs and has been pushing hard into the AI market. Google has been designing its own TPUs for years. Amazon has Trainium and Inferentia. Microsoft has Maya. Meta is building custom silicon. And there's a whole rotating cast of well-funded AI chip startups promising to dethrone the king any day now. So why does Nvidia keep its central role? The short answer is that Nvidia stopped being a chip company a long time ago. The chip is the product, but the ecosystem is the trapdoor. When you actually look at what Nvidia sells today, it's not a component, it's a stack. There's the GPU itself, obviously, but around it sits networking hardware that connects thousands of GPUs at extreme speed. Full server systems engineered specifically for AI. The CUDA platform. AI libraries for everything from language to biology. Enterprise software products. Deep partnerships with every major cloud provider. Reference architectures for building AI factories. And a developer ecosystem with millions of people who already know how to use all of it. Buying a chip from Nvidia isn't like buying a single pickaxe. It's like buying an entire pre-designed mining operation. The machinery, the rail tracks, the trained workforce, the geological maps, the supply chain, even the language the workers speak. All of it comes in the box. That's why companies that are theoretically sophisticated enough to build their own chips still keep buying from Nvidia. It's not because they can't make silicon, it's because reproducing the entire surrounding ecosystem from scratch is a decade-long project. And they don't have a decade. They have a quarter. This is what the fiscal 2025 numbers really mean. When data center revenue hits $115.2 billion in a single year, you're not looking at a hardware company having a good year. You're looking at the center of gravity of a company shifting permanently. Nvidia has become something closer to a toll road for the entire AI economy. It almost doesn't matter who's driving. Startup, hyperscaler, sovereign lab, the toll gets paid. AI companies want to differentiate on models, products, and user experiences. But underneath all that differentiation, they keep converging on the same infrastructure. Nvidia didn't just sell the pickaxe. It designed the mine, trained the miners, and built the roads leading to the gold. But no moat is permanent, and any honest version of this story has to take the risks seriously. Competition is intensifying. AMD is closing technical gaps. Custom chips from Google, Amazon, Microsoft, and Meta are real, and they're specifically designed to reduce dependence on Nvidia. Customer concentration cuts both ways. Nvidia's biggest customers are also the companies most motivated to build alternatives, because every dollar they send to Nvidia is a dollar they wish they were keeping. Supply chains for high-end GPUs are fragile, dependent on advanced manufacturing, exotic packaging, and specialized memory that only a handful of companies in the world can produce. Geopolitics adds another layer, with export controls reshaping who can buy what and from where. There's also a deeper economic question hanging over the entire industry. If the AI applications being built on top of all this infrastructure don't eventually generate proportional revenue, the pace of infrastructure build-out could slow, or even reverse. And if new architectures emerge that require dramatically less compute, smaller, more efficient models, or radically cheaper inference techniques, the demand curve itself could bend. That said, Nvidia isn't standing still while these threats develop. They have an enormous installed base, deep developer familiarity, a software ecosystem competitors can't replicate quickly, strategic supply relationships, and an extraordinarily fast product cadence. The crown is contested, but it's still firmly on their head, and whatever happens next, one thing is already clear. Nvidia has redefined what it means to sell infrastructure during a technological revolution. So let's close the loop. In every great technology boom, the public stares at the gold diggers, the famous apps, the celebrity founders, the viral demos that fill our timelines. But the deeper power often sits one layer beneath, in the tools, the standards, the platforms, and the ecosystems that everyone else has to build on top of. Nvidia won because they did three things right at the same time. They built hardware aligned with the future before that future arrived. They invested in software and developer ecosystems years before the mass market understood why that mattered. And they positioned themselves not as a chip vendor, but as the foundational platform of an entire industry. The AI gold rush is going to produce winners and losers. Some of today's hottest companies will fade. Others we haven't heard of yet will become household names. But for this stretch of history, Almost every miner still has to walk past Nvidia's storefront on the way to the dig site. If you want, the next video can flip the question and ask the harder one. What could actually break Nvidia's grip on AI infrastructure? Because in technology, no empire lasts forever. Hit like, subscribe, and drop a comment telling me what you think. Is Nvidia an AI bubble waiting to pop, or the Standard Oil of the compute era? I'll see you in the next one.